The following scenario is hypothetical and presented for educational and entertainment purposes. The world did not become quieter when radio failed to exist. It became slower, denser, and far more mechanical. In this parallel century, the decisive experiment never works. No clean transmission through open air, no proof that information can leap invisibly across distance, no moment that convinces civilization the atmosphere itself can be turned into infrastructure. At first, the loss seems technical, almost trivial. A missed triumph in a laboratory crowded with sparks, coils, and mathematical confidence. Yet, from that absence, an entirely different scientific age begins. Without radio, communication remains chained to matter. Messages still travel beautifully, but only through wire, paper, cable, and physical transport. Engineers do not dream of bathing continents in signals. They dream of thicker insulation, stronger relays, denser switching stations, and oceans webbed with more copper than any economist of the old timeline would consider reasonable. Cities grow around communication trunks the way ancient towns once grew around rivers. Ports matter more. Telegraph unions become more powerful. Mountain ranges, deserts, and storms retain their old tyranny over human coordination because the sky never becomes useful. The scientific damage runs deeper than delayed convenience. Radio in the known world was not just a tool of broadcasting. It was proof that nature allowed invisible traffic. Remove that proof, and entire fields mature differently. Electromagnetic theory survives in textbooks, but to investors and statesmen it feels abstract, underexploited, faintly disappointing. Universities steer bright minds toward chemistry, precision machining, and wired electrical systems. Young inventors grow up believing distance is a brute fact to be managed, not conquered. Their ambitions shrink accordingly. The modern imagination becomes local. Military science changes with equal force. Navies still depend on flags, lamps, cables, and vulnerable coded dispatches. Armies move with larger delays between command and consequence. Weather forecasting advances more slowly because atmospheric sensing networks remain fragmented. Aviation, lacking reliable wireless coordination, develops under harsher constraints. The sky is still open, but it is not yet connected. Even the public idea of emergency remains different. A ship in trouble is not a voice in the dark reaching every receiver at sea. It is an object vanishing beyond the horizon. And then, as the wired world reaches its limit, a new question begins to frighten the century. If humanity cannot speak through the air, what else has it misunderstood about the air itself? By the middle of the 20th century, that question stops sounding philosophical and starts shaping civilization. Once engineers accept that the atmosphere cannot be trusted as a carrier of intelligence, they begin to redesign modernity around enclosed pathways. The result is not a weaker world, but a stranger one. Communication networks become as physical and strategic as railroads. Every industrial nation pours steel, rubber, and copper into continental wire grids, underground pulse tunnels, insulated relay towers, and seabed trunk lines so vast they are treated as organs of the state. Information no longer floats. It must be manufactured, routed, guarded, repaired. In scientific terms, this pushes innovation toward material efficiency instead of field manipulation. The century becomes obsessed with reducing friction in contact-based systems. That obsession changes computing long before it changes popular life. In the known world, wireless thinking helped normalize the idea of invisible transmission, remote coordination, and distributed systems. Here, those concepts emerge through a harsher route. Machines are built first to compensate for the slowness of human switching. Electromechanical routing engines evolve into room-sized logic directors that can prioritize telegram streams, reroute emergency lines, and compress coded traffic for major governments and financial exchanges. Data science is born not from abundance, but from bottleneck. Scientists ask a brutally practical question. If every message must occupy expensive physical space, which messages deserve to survive? The answer transforms economics. Markets operate in thicker time, where price differences linger longer between cities and continents. Local manufacturing stays competitive because global coordination is clumsier. Mass culture remains fragmented too. No household gathers around a broadcast voice pouring identical news into millions of rooms at once. Instead, public consciousness forms through delayed print syndicates, wired audio halls, city projection networks, and subscription listening booths. Entire generations grow up without a true simultaneous national moment. Politics becomes more regional, rumor more durable, and propaganda more infrastructural. Whoever owns the switching backbone shapes reality. Science pays another price in silence above the planet. Without radio engineering driving miniaturization of transmitters, antennas, and remote sensing, the path to satellites is delayed by decades. Rocketry exists, but space remains mostly ceremonial, spectacular, and blind. An object can be launched upward, yet the dream of instant contact with it remains unreliable and expensive. Astronomers, meteorologists, and navigators all work with partial skies. Then a classified polar research program detects something impossible. The upper atmosphere is not mute at all. It is alive with natural electromagnetic structures no one learned to use, and one laboratory believes they may be teachable. Once that discovery escapes the laboratory, science stops mourning the missing invention and starts pursuing a more dangerous possibility. Radio was never invented because the first generation asked the wrong question. In this world, the air was not empty space waiting to be pierced by a signal. It was a living electrical medium, layered, unstable, selective, almost ecological in behavior. The old experimenters had tried to force messages through it, as if the atmosphere were a passive tube. The polar teams uncover the opposite truth. The sky does carry patterns, but only when transmission behaves less like a command and more like a negotiation with charged layers, geomagnetic tides, and naturally recurring bands of resonance. That insight triggers the century's single great scientific climax. Governments, universities, and industrial syndicates race to build what they call adaptive field communicators, machines that do not broadcast in the familiar sense, but tune themselves to atmospheric windows that open and close like weather. The first successes are brief, erratic, and terrifyingly expensive. A coded burst launched from Greenland appears over Patagonia with no cable, no relay, and no ship between them. Then the same system fails for weeks because solar turbulence shifts the usable layer by a few kilometers. Communication science becomes half physics, half planetary biology. Meteorologists, plasma theorists, and information engineers suddenly belong to the same discipline. For the first time in generations, children grow up believing distance may not be permanent after all. But civilization has been shaped too long by confinement to adapt cleanly. Economies built on cable empires resist the new science. States fear a world where information can no longer be bottlenecked through guarded infrastructure. Cultures that evolved regionally under delayed exchange begin to collapse into one another at frightening speed the moment adaptive transmission stabilizes. Old industries call it chaos. Young scientists call it liberation. Both are right. Because when the sky finally opens, it does not restore the world that might have been built by radio in the old timeline. It creates something stranger, a civilization that reaches invisible connection only after mastering the full weight of material delay. And that is the final scientific irony of this parallel history. A world denied radio does not remain smaller forever. It becomes more disciplined, more mechanical, more locally rooted, until one late breakthrough teaches humanity that the atmosphere was never silent. It was merely waiting for a species intelligent enough to listen the right way.